Okay, question 8. A continuous random variable x has the probability density function as follows here, okay? The following diagram shows the graph of y equals fx for x is between a and b. Right, given that c is greater than a plus b over 2, find an expression for the median x in terms of a, b, and c. Right, cool. So let's talk about a little bit. Let's show what's going on here. So we have this PDF up here, which we're going to obviously need to use, and we quite kindly we're told this idea here that C is essentially greater than the average of A plus B of A and B. We can also just see that from our graph here. If we just draw, let's go with purple. We just draw this line down here. This is essentially where this point, or the apex of the triangle. That is where that's not very good, is it? That's where the function changes. So that means that's going to have to be C there. Okay. Now, in order to find an expression for the median, we're going to have to essentially split this triangle in half. Okay. So let's say if we call let's call the top of our triangle up here, let's just call this we'll call it point D. All right. Triangle ABD, the area will have to equal 1. All right. Now, if we introduce put the median down here. All right, and then let's say we find a point here. All right, E, let's just call that E. That means triangle AME will have to equal a half, okay? Because half of the values lie to the right of the median and half the values lie to the left of the median, okay? And so from that, we can now go ahead and sort of calculate or sort of use the fact that the median or the triangle AME is equal, the area of that triangle is equal to a half. We can use that to then now find an expression for the median N. So with this triangle here, AME, the base will be just M minus A, which is just this line here. All right, so that's just going to be equal to M minus A. And the height is going to be when we substitute M into our probability density function. Now, since we know that M is to the left of our of C, that means we're going to have to lob M into this probability density function. All right, bear with me here. I'm going to try and make that slightly better. In fact, we'll just do two lines, right? That's probably going to be better. I will just put a box around it. That's probably even better still. So we're going to need to use this part here, this probability density function, or the first part of our probability density function, because M lies within A to C. All right, cool. So that means then the height of our triangle will be equal to, and we substitute M into this guy here. And so what I'm going to do actually is just copy this down so I don't have to keep on going up and down. Let's just paste that there. So the height is going to be 2 over B minus A, C minus A, and then multiplied by M minus A, because we're substituting in M for X. All right, so now we have the base of our triangle, we have the height of our triangle, and we know the formula for the area of a triangle is equal to half base times height. All right, so we can say, therefore, the area of, say, triangle AME is equal to, well, we know it's equal to a half, which is equal to 1/2 times by, or in fact, we'll just put times by the base, which is over here, M minus A, multiplied by the height, which is here, which I am going to just, we'll put in some square brackets and copy it down. Cool. And then, and actually, hold on, let's make it slightly smaller. Nice. Okay. So now we have, an expression for the area of the triangle AME, which has M in it, and we can go ahead and sort of solve this now. So what we can do is say a half is equal to, we could say that this half here will cancel with this 2 up here. All right. Equally, you could have divided both sides by a half, and then gone 1 on the left-hand side. Any way you want, you can sort of rearrange this equation to find M. All right. So we're going to end up having M minus A multiplied by M minus A on the numerator. So we'll just get M minus A squared. Let's move this slightly over, eh? And then we're going to get on the denominator B minus A multiplied by C minus A. C minus A. All right, lovely. And then so now what we can do is, let's rearrange this. And so let's multiply both sides by B minus A multiplied by C minus A. And so let's just take this down and we'll say what we're doing. We're going multiplying by B minus A multiplied by C minus A. Okay, and so that's going to get rid of this denominator here. So we're just going to get B minus A. In fact, I'm going to kind of copy it. Let's just bring this down here. B minus A over C minus A, and then that's going to be over 2 is equal to M minus A squared over 2 equal to M minus A squared. As per usual, I'm probably going to run out of room, so I'm just going to add a new page on the bottom here. Okay, cool. And then what we can do here is we can square root both sides. So yeah, we'll put one more step into here. So square root both sides, and so we'll get the square root of B minus A over C minus A, B minus A multiplied by C minus A over 2. Square root of that is going to equal just M minus A is equal to M minus A. And then now we'll add, in fact, we'll just copy the exact same step down to our new page, okay? Bring that down here. And then now next step, we're going to add A on both sides. All right, and actually what I'm going to do is I need to lob in, if we're taking the square root of anything, we're going to have to remember to lob in our plus and minus sign, okay? We end up only needing the positive version of this since M is greater than 0. So yeah, well M is greater than A, so we need it to be the positive version, but for it's good practice to always lob that in. I'll show you why that turns out. So here we're going to add an A, so plus A, and so we'll get, and that's, we'll go, and we'll say M is equal to this plus and minus square root of B minus A times C minus A over 2 plus A. All right, and then as I said, since we'll write since M is greater than A, we don't need this this negative version, because that would make it make this expression less than A. All right, so since M is greater than A, therefore M is equal to, let's go with A plus the square root of this. Let's go here. And now that is the answer to question 8.